Bidirectional text is text containing text in both text directionalities, both right to left and left to right. It generally involves text containing different types of alphabets, but may also refer to boustrophedon, which is changing text directionality in each row. Some writing systems of the world, including the Arabic and Hebrew scripts or derived systems such as the Persian, Urdu, and Yiddish scripts, are written in a form known as right to left, in which writing begins at the right-hand side of a page and concludes at the left-hand side. This is different from the left or right direction used by most languages in the world. When LTR text is mixed with RTL in the same paragraph, each type of text is written in its own direction, which is known as bidirectional text. This can get rather complex when multiple levels of quotation are used. Many computer programs fail to display bidirectional text correctly. For example, the Hebrew name Sarah is spelled Sin, then Resh, and finally Hey. Note: some web browsers may display the Hebrew text in this article in the opposite direction. Bidirectional script support. Bidirectional script support is the capability of a computer system to correctly display bidirectional text. The term is often shortened to BD, or BD. Early computer installations were designed only to support a single writing system, typically for left-to-right scripts based on the Latin alphabet only. Adding new character sets and character encodings enabled a number of other left-to-right scripts to be supported, but did not easily support right-to-left scripts such as Arabic or Hebrew, and mixing the two was not practical. Right-to-left scripts were introduced through encodings like ISO IEC 8859-6 and ISO IEC 8859-8, storing the letters in writing and reading order. It is possible to simply flip the left-to-right display order to a right-to-left display order, but doing this sacrifices the ability to correctly display left-to-right scripts. With bidirectional script support, it is possible to mix scripts from different scripts on the same page, regardless of writing direction. In particular, the Unicode standard provides foundations for complete BD support, with detailed rules as to how mixtures of left-to-right and right-to-left scripts are to be encoded and displayed. Unicode D Support. The Unicode standard calls for characters to be ordered logically, that is in the sequence they are intended to be interpreted, as opposed to visually, the sequence they appear. This distinction is relevant for BD support because at any BD transition, the visual presentation ceases to be the logical one. Thus, in order to offer BD support, Unicode prescribes an algorithm for how to convert the logical sequence of characters into the correct visual presentation. For this purpose, the Unicode encoding standard divides all its characters into one of four types: strong, weak, neutral, and explicit formatting. Strong characters strong characters are those with definite directionality. Examples of this type of character include most alphabetic characters, syllabic characters, hanideographs, non-European or non-Arabic digits, and punctuation characters that are specific to only those scripts. Weak characters weak characters are those with vague directionality. Examples of this type of character include European digits, Eastern Arabic Indic digits, arithmetic symbols, and currency symbols. Punctuation symbols that are common to many scripts, such as the colon, comma, full stop, and the no break space also fall within this category. Numbers, unless a directional override is present, numbers are always encoded big endian, and the numerals rendered LTR. The weak directionality only applies to the placement of the number in its entirety. Neutral characters neutral characters have directionality indeterminable without context. Examples include paragraph separators, tabs, and most other whitespace characters. Explicit formatting explicit formatting characters, also referred to as directional formatting characters, are special Unicode sequences that direct the Unicode algorithm to modify its default behavior. These characters are subdivided into marks, embeddings, isolates, and overrides. Their effects continue until the occurrence of either a paragraph separator, or a pop character. Marks: if a weak character is followed by another weak character, the algorithm will look at the first neighboring strong character. Sometimes this leads to unintentional display errors. These errors are corrected or prevented with pseudo-strong characters. Such Unicode control characters are called marks. The mark or U+200F right-to-left mark is to be inserted into a location to make an enclosed W character inherit its writing direction. For example, to correctly display the U+2122 accent trademark sign for an English name brand in an Arabic passage, an LRM mark is inserted after the trademark symbol if the symbol is not followed by LTR text. If the LRM mark is not added, the W character accent will be neighbored by a strong LTR character and a strong RTL character. Hence, in an RTL context, it will be considered to be RTL, and displayed in an incorrect order. Embeddings. The embedding directional formatting characters are the classical Unicode method of explicit formatting, and as of Unicode 6.3, are being discouraged in favor of isolates. An embedding signals that a piece of text is to be treated as directionally distinct. The text within the scope of the embedding formatting characters is not independent of the surrounding text. Also, characters within an embedding can affect the ordering of characters outside. Unicode 6.3 recognized that directional embeddings usually have too strong an effect on their surroundings and are thus unnecessarily difficult to use. Isolates. The isolate directional formatting characters signal that a piece of text is to be treated as directionally isolated from its surroundings. As of Unicode 6.3, these are the formatting characters that are being encouraged in new documents once target platforms are known to support them. These formatting characters were introduced after it became apparent that directional embeddings usually have too strong an effect on their surroundings and are thus unnecessarily difficult to use. Unlike the legacy embedding directional formatting characters, isolate characters have no effect on the ordering of the text outside their scope. Isolates can be nested, and may be placed within embeddings and overrides. Overrides. The override directional formatting characters allow for special cases, such as for part numbers, and are recommended avoided wherever possible. As is true of the other directional formatting characters, overrides can be nested one inside another, and in embeddings and isolates. POPs. The POP directional formatting characters terminate the scope of the most recent embedding, override, or isolate. Runs equals. In the algorithm, each sequence of concatenated strong characters is called a run. A weak character that is located between two strong characters with the same orientation will inherit their orientation. A weak character that is located between two strong characters with a different writing direction, will inherit the main context's writing direction. Table of possible BD types Scripts using bidirectional text. Egyptian hieroglyphs Egyptian hieroglyphs can be written bidirectionally, where the signs had a distinct head that faced the beginning of a line and tail that faced the end. Chinese characters Chinese characters can be written in either direction as well as vertically, especially in signs, but the orientation of the individual characters is never changed. This can often be seen on tour buses in China, where the company name customarily runs from the front of the vehicle to its rear that is, from right to left on the right side of the bus, and from left to right on the left side of the bus. English texts on the right side of the vehicle are also quite commonly written in reverse order. Boustrophedon Boustrophedon is a writing style found in ancient Greek inscriptions and in Hungarian runes. This method of writing alternates direction, and usually reverses the individual characters, on each successive line. See also, internationalization and localization, horizontal and vertical writing in East Asian scripts, writing system directionality, combining Cyrillic millions, transformation of text, boustrophedon. References. External links, Unicode Standards Annex No. 9 The Bidirectional Algorithm, W3C Guidelines on Authoring Techniques for Bidirectional Text, includes examples and good explanations, GNU Free BIDA Free Implementation of the Unicode Bidirectional Algorithm, ICU International Components for Unicode contains an implementation of the bidirectional algorithm along with other internationalization services, UCData. Pretty Good BD algorithm library, a small and fast bidirectional reordering algorithm that works pretty good, but not necessarily compliant to the Unicode algorithm. Bidirectional scripts in desktop software working group for supporting BD and free software. Contains several links to readings and implementation regarding BD and computer systems. Another wiki about BD, bidirectional text, examples and practical advice. .NET BD implementation, a freely available rather final version of Israeli Standard 5194, bidirectional text editing, consequences of BD and Quran pages, work in progress on new version of BD editing standard plus reference implementation, series of articles about pitfalls of BD programming, DRenderer an application that illustrates the shaping and layout of complex text in bidirectional paragraphs using FreeBID, FreeType, and HalfBuzz.